Okay, so I mentioned to you guys that I was going to record a quick video on 5.1 and 5.2, and generally speaking, it's just rules of exponents, so let's get started. The first thing we're going to look at is our first four rules, and they're all the same ones that we covered in section 4.2, so I'm going to go through them pretty quickly, but just to reiterate. First one is the product of powers, where when you multiply two things with the same base, you add the exponents. So we see the b plus c together up here. Okay, this b plus c right here, it's the sum of that exponent and that exponent. As an example, we're going to see if we had x to the second times y to the third times x to the seventh times y to the fifth. Really, it's quite simple to look at it this way and say, well, this is really two x's, and there's really 7 of them there. So there's 2 x's there, and there's really 7 there, which make up a total of 2 and 7, or 9 x's. Here it's like there's 3 y's and 5 y's. There's 3 of them there, and 5 y's there, giving us a total of 8 y's. Second rule is the zero exponent rule. Remember, the zero exponent rule tells us any number to the zero, any real number to the zero is 1. And again, remember that a, in this case, cannot equal 0, though, because you'll learn in pre-calculus and calculus about the fact that 0 to the 0 is called indeterminate. If you want to see where this comes from again, it's a simple way to look at it. Look at your powers of 2. 2 to the third is 8, 2 to the second is 4, 2 to the first is 2, and you'll notice that each increment is reducing by half. So the next reduction here is going to be 1. And look at the exponents, they're all going down by 1. 3, oops, let me use that. 3, 2, 1. So the next exponent's got to be 0, and on the right side it's got to be 1. So we're going to see that we have 2 to the 0 simply equals 1 here. Alright, power to a power. This example is very simple. If we have two powers, okay, one of them that is in the inside and one is on the outside, just multiply them. Okay, it's raising a power to a power. To see the proof of that, we can take a look at this example. X to the third to the fourth is just x to the 12th. Where does that come from? Well, it's x to the third 4 times, because there's 4 right here. X to the third, x to the third, x to the third, x to the third. Well, going back to the first rule, you would simply add these 4 together, which give you 12. Let's make it easier. Just remember to multiply those two. The power of product is similar to the distributive law. Okay? When you have a distributive, you remember this, becomes where you take the c and distribute it to both. Well, it's the same thing here, really, except now we have a product, so it's going to look a little different, but we're distributing the exponent. This exponent here that we see, the c, we're going to take it and put it here and here. So we're distributing it to both terms. Different law, though. It's not distributive. You want to take a look at the example numerically. Think of this one where we have 4 times 2 to the third. Well, 4 times 2 is just 8. 8 to the third is 512. Or you could say 4 times 2 to the third is 4 to the third times 2 to the third. If you take this 3 and distribute it to both. 4 to the third is 64. 2 to the third is 8. 64 times 8 is still 512. Same answer. Quotient of powers. Here's our new rule. So 1 through 4 was again a repeat from section 4.2. From this point on here, these are going to be the new rules. Quotient of powers is simply the opposite of addition. Remember, if you had like the product of powers, you had, oops. So again, when you have a product of powers, you would have a to the b times a to the c equals a to the b plus c. Instead now, we have a to the b over a to the c, and instead of adding the two here, we're going to see that we have subtraction as our rule. Look at an example of this, and the way I think about it always is that if it's x to the 7th over x to the 4th, it's like there's 7 x's up here along the top, and there's 4 along the bottom. So we'll see that these 4 will cancel. So again here, we're noticing that we have 7 up top, 4 down below. So if we cancel them, we'll see that 3 of these guys are left over. Which 3 might you say? Well, it doesn't matter, but these first 3 are left over. X to the third. Now if we scroll down a little bit and look at this next example, we're going to see we have the quantity h cubed n to the fourth and the quantity h squared n to the third. Start with all of your rules. Distribute your 4 to both. You're going to have 4 and a 3 giving you the 12. You're multiplying the powers. There's a 1 here really, times the 4 gives you the 4. Next, take the 3 distributed to the 2 giving you, oops, this should be a 6. Typo. Okay, h to the 6th and to the third. And then we're going to have 12 over 6. Put some h to the 6th still. 4 minus 3 gives you just n to the 1. Okay, so again, our final answer is h to the 6th n to the 1. I'll fix that typo in your notes online. Alright, let's keep going here. Alright, now comes the question though, what happens when the numerator's degree is less than that of the denominator? So you can end up subtracting a number. You're going to take that number and subtract a bigger number from it. So let's see what happens here. First, if we look at our rule and we had m to the 4th over m to the 6th, you would simply take the 4 here minus the 6. Well, that's negative 2. But what does m to the negative 2 really mean? And this is where we get into our negative exponent law. And what we're going to see is this. Write it this way instead. Write m to the 4th as mmmm. Write m to the 6th as mmmm, which looks like So we have m to the 4th over m to the 6th. Take 4 of these and cancel with 4 of these. You're going to notice how many are left. Only these 2 at the end. Well, what's left up top? When these 4 up top cancel, you're simply left with a 1. So you're left with 1 over m times m, or 1 over m squared. So that tells me that if I did it this way, I get m to the negative 2. And if I do it this way, I get 1 over m squared. But they got to be the same. So m to the negative 2 is really equal to 1 over m squared. So if I generalize and write a rule for that, I can see my rule is quite simple actually. And ignore the right part of the rule for a second, please. Take a look at your rule. Your rule is right here. Your rule says a to the negative b. Whenever you have a negative power, like we had here, this negative 2, we ended up with 1 over the same power, but it was positive. So a to the negative b is 1 over a to the positive b. So you take whatever the negative power is and move it from the numerator to the denominator. Well, now let's generalize with the second part of the rule, and we'll see here that if we ever have a negative exponent, anytime, and we have a numerator and denominator, we make the exponent positive, but we move whatever this term is to the bottom of the top. And let me show you this. This becomes a to the negative c over b to the negative c. But I need to take this a to the negative c, like we had here, and move it down below as a positive. So this ends up going down here as a to the positive c. While the b that has a negative c here is going to move up here as b to the positive c. So that's what this rule is telling us. If you have a negative exponent, make the exponent positive and just move your numerator and denominator. An example here we're going to see. Take a look at this example here. We're going to have x to the third, y to the second over x to the seventh, y, z to the negative third. So what I would start by doing is simply looking at this and saying, alright, well you can do it several ways. You can cancel everything that you see that's possible, so you can reduce these and say that, alright, there's 4 of these left once you cancel 3 and leave x to the fourth in the bottom. Or you can use your rule and do 3 minus, or you can use your rule and use 3 minus 7 and get this negative 4 up top. 2 minus this 1 leaves a 1 up top, and I left the z to the negative third down below. And what we'll notice is that we have a negative exponent here, so take this expression, move it down here as a positive, take this negative, move it up here as a positive. Okay, another way to do this though is to take this expression and write it out. We'll think of it right now. You never do this really, but write it out in your head. And what you'll notice is that these 3 x's cancel with these 3 here. One of these y's cancel one of these y's. And what we're left with is y over x to the fourth. But then we have this z to the negative third. So if you go ahead and do this now, take this, cross it off, and put it z to the positive third up top, you'll see that you end up with y z to the third, or y z to the third, over x to the fourth, x to the fourth. So you could always cancel in your head if it makes it easier. I do that sometimes too. The last example is a power of a quotient. It's the same thing as a power of a product, where we had like a distributive law here. We take that c and we kind of distribute it to both of those. Same thing. Okay? Same thing. There's an exponent on the outside here. Just take it and put it on both of these two values. Okay, so take the exponent here, distribute it there and there. Let's look at an example of this. Here we've got the negative 3 as the exponent. So notice right away, before I did anything, I used my negative exponent rule. I made this negative 3 a positive 3. And I took everything in the numerator and put it in the denominator. And everything in the denominator and put it in the numerator to make this a positive. Then you'll notice that I took these 4 y's and moved them down here. So these 4 y's went down to the bottom with these 2, making this y to the 6th. There's 3 x's here and 2 up top. So what I can do is simply go ahead and say, alright, well let me cancel these 2 with 2 of these, leaving 1 x behind. These 4 move down. So now I've got an x left behind on the bottom. Well, there it is right there. And I've got y to the 2nd, and this is a positive y to the 4th moving down, making y to the 6th. Now this is to the 3rd power, so I take the 3rd and I distribute it. So this is really 1 to the 3rd up here. But 1 to the 3rd is just 1, so I don't need that 3rd there. Then I take this 3rd and distribute it down here. That becomes x. This is x to the 1 to the 3rd is x to the 3rd. Y to the 6th to the 3rd, take the 6 times the 3 and multiply them to give you y to the 18th. Your homework for this section is out of 2 sections, section 5.1 and section 5.2.